today on the on.net show, we're going to be talking with Immo about nullable reference types. This is how you can get rid of all those null reference exceptions forever. Welcome to another episode of the on.net show. Today we're going to be talking with Immo, and we're going to be talking about nullable reference types. Okay, so you've been on the show before, but how about you introduce yourself for the audience? You're more famous than me, so
No, I'm not famous at all. At least I hope. If I'm famous, then probably for the wrong pictures. So I'm Immo. I'm a program manager of the .NET platform team, and I specialize in anything related to API design, the base class library, or BCL as we call it, and all the fundamental types, all the things that are fun.
Yeah, awesome. And so what are we talking about today?
So today we're talking about a feature that you probably have heard about many times, but we want to go a bit more into detail on how the feature works and why the feature is relevant for library authors and what you need to know about it. And specifically, the feature is called nullable reference types, which is somewhat funny because people, what they really want is the thing to be non-nullable, when they don't want it to be nullable.
It's kind of confusing. And also, so we have like what, 10 years ago or something like that, nullable value types was introduced into the language. And so up until that point, value types could not be null.
Right.
So it's kind of the opposite direction. So are these kind of like a meeting in the middle sort of thing? Sort of,
yeah. The interesting thing with value types is that value types and reference types have different representations in memory, right? And so reference types could always be nullable, right, whether you wanted that or not. For value types, usually the way you deal with that is with what we call sentinel values, right? You just say 0 is my null value, right? Like you have an age property and you say, well, if the value is 0, then it's not set, right?
Mm-hmm.
But that doesn't always work when pretty much every value is a meaningful value, right? In this case, like sentinel values are hard to do, right? And so nullable value types allow you to basically say, well, imagine you have a wrapper type that basically carries a flag that says is the value actually present or not, right? And that's basically what it is. But it still has a different representation, right? And then nullable reference types is basically a feature where the underlying memory representation is exactly the same as before. It's just that the type system is more enlightened about your intent. You can say, you know, I don't want this property to be null. And then the compiler can help you figure out cases where you may accidentally have it set to null when you didn't want to. That's basically what the feature is, in a nutshell.
So should I think of this more as a static analysis style feature as opposed to like runtime enforcement?
Yeah, the runtime doesn't know about this thing at all, right? Like there's obviously artifacts that you can observe at runtime, like custom attributes that are applied to APIs, and we will probably also expose reflection APIs for you to inspect programs and say, is this property meant to be nullable or not? But
so we don't have that yet.
But we don't have that yet. But so the way to think about this is, it's a compiler feature, right? So the C# compiler has special knowledge baked in that looks at your code and says, oh, you did an if check to say if x is not null, and then under the if we assume that x is not null because you just tested for null, right? Basically, that's the idea.
So I sometimes hear this term used. So as you know, I sit with the compiler team and I hear all their conversations. So I sometimes hear this term used called flow analysis.
Yes.
So I think that relates to this feature.
Yeah, let's maybe look at some sample code to make it a bit more easy to understand. But so basically what we have here is a typical program that does what you think it does. It crashes with null reference exception.
Oh,
right?
man.
We've all seen that many times. And so what's happening here is you have a customer that has a first name, middle name, and last name. And all we do here is we just sum them up. And of course, if middle is not set, then we get a null reference here. Right? If I run this in the debugger,
a lot of people can probably figure out what is going on.
What people are, I'm actually surprised many people don't know this. If you look at the exception message closely, we actually tell you where the null reference exception came from, right? Because like clearly it's on this line, right? You know that, but which of the three things is the one that was causing the null reference? And it's the middle name getter that returned null. So like you don't have to guess anymore. You don't have to hover all of these things. Now you can actually see that this is the one that's the offending thing. And so the feature that nullable reference types allows you to do is to say, well, I expect this to be nullable. and I don't expect these to be nullable. And so now you can see there's a squiggle here, and the squiggle tells you that annotations are not available because you haven't enabled them effectively, right?
Okay.
So this is a feature you have to opt in, right? Even if you use the latest version of C#, existing code is a thing, as it turns out, right? And like none of the existing code is aware of nullable, right? And so that means you generally can't say that every single time I said string, I meant non-nullable string. That's probably true, like what, 85% of the time maybe, but not all the time, right? That's why the feature is something you have to opt in. And so the way we can do this is either by opting in the entire project, or you can actually do it file by file. But for new code, it probably makes sense to do the entire project.
This is one of those like choose wisely features.
Yes, and you can, if you turn on an existing code basis, you will, depending on how your code is, it might be harder or easier.
Okay, so now what's happening?
So basically what we now have here is, there's a few things happening right now. So first of all, if we just zoom in here, if we just look at the definition of this type here, right? Oopsie daisy. This type is basically saying there's two properties, first and last. I said they're non-nullable, but they're never initialized by the constructor, right? So, well, that means if somebody just news it up, clearly they're null, right?
Yes.
And so
if you, in the constructor, set them both to string.empty, then you'd be
yeah,
good.
or you just have the other thing you can do is you can just make them private setters, for example, and then just have a constructor that takes them as arguments. And then the only way you can get a customer is if you set first and last, right? That would be the way to do it. But then more importantly, we also get this guy here where we say, well, here you're doing this thing, and here's exactly the time where I'm just dereferencing middle. And we said explicitly, well, we expect middle can be null. And now the compiler tells you that, well, you didn't check for that. And so to your earlier question, I can just do this, right? I could just say if customer middle is null, else I do this. So we would say in length. Actually, let's do this. And then we just do the simple version where we say if middle is null, we only sum up the first two. If middle is not null, then we use it. And what you can see here is now the compiler doesn't give you a squiggle anymore because the compiler knows that you tested this for null. And that's the flow analysis part where I didn't have to introduce a local variable that is marked non-nullable. The compiler knows that in this block here, you only execute this code if middle is not null.
So how smart is the flow analysis? So in that case, it's pretty straightforward because you have an if statement, and then you just go into each of the branches,
right.
And you can know whether middle is null in each of the branches. That seems like a fairly straightforward test.
So I'm not a compiler guy, so I don't know what the actual technology is or the actual scientific approach, whatever you want to call this, is being referred to. But basically, the compiler only looks at individual variables and whatever checks you have in place, right? So for example, I can have relatively complicated expressions here where I have multiple variables and certain things are mutually exclusive and whatever. The compiler doesn't track that, right? It's not a full theorem prover where we satisfy each of the variables and conditions and figure this out. It's simple in the sense that things like this we detect. Other things that we also detect, right? If you say, if this is null, you can say environment.failFast, for example. You can say whatever, right? And then I think it might be because it's not. I probably have an older build where that the APIs here are not annotated yet. But basically, if failFast is annotated, that we know that this call will never return. So basically, the program will terminate when you call this thing, which now means that if middle is null, well, then this code here is not reachable, right?
Right.
So the compiler, like in the final version of .NET Core, you will not get a squiggle here.
Actually, on that note, could you F12 that? Or maybe we're not going to see them because you're using the wrong build.
yeah, I'm now going to the implementation. You can see this.
No, there's something there. That
I probably have an older version of the compiler that doesn't know that that attribute then.
what that means.
Yeah, so basically, we have basically annotated this and says this method never returns.
Right, but can you explain, so you explained the one,
Yep.
which is does not return. Can you
Yep.
explain what the other one means? Because
This
it's
one
not
here?
super intuitive on the face of it.
Yeah, this one is not what you are supposed to see. Like that's basically one of those things where our type system doesn't allow you to like actually put question marks and exclamation marks on the actual APIs, but you can say string exclamation mark or string question mark here, because the CLI has no representation for this, right? And so the way we do this, we just have a custom attribute that we apply to that, and then that basically means that basically this thing is nullable.
Okay, that's what the 2 means?
Yes.
Is there a reason that an enum wasn't used there?
Because like if you look at nullable context, it has 2 different arguments. One is a byte, one is a byte array. So if you have like an IEnumable of string, or an IEnumable of a key value pair of a string and a string, the first string might be nullable, the second one might not be. And so we have to perhaps have multiple numbers there, and it's just the most compact representation that we could have. And even if we use an enum here, like especially when you have like an array with like 4 elements, like you have to flatten the type in your head to actually figure this out. And so the final version of the product will not show you this. Instead, it will just put a question mark here, right? That's the end. That's the intent.
Okay. We're just not there yet.
But that's basically how it's being encoded, if you will, in metadata. And yeah, so that's one example, right? Another one that you can do that is very similar is you can just say, I assert that customer middle is not null.
Or you could write is object.
And now basically, yeah, or that, right? Would do the same thing. Right, and as you can see, the squiggle disappears here because the compiler knows that this code is unreachable if this is null.
Yeah, although don't asserts only run in debug builds?
That's correct, but like that's if you think about the feature in general, right? It's not meant to be a bulletproof system.
Right.
It's really meant to capture the intent the developer had with the APIs and help you write correct code, right?
Yeah, actually, it's totally in the spirit because, yeah, it's totally in the spirit of the rest of it.
But like if you look at the assert one here, it's similar here. We have a custom attribute applied to the parameter that says this method will not return if this condition is false.
Oh, I see.
And so that's how the compiler knows that, well, the condition is this value is not null. So if the value is null, this call would have never returned.
Yeah, so this is starting to show the more conditional nature of the feature.
Yes.
Do you have any other favorites that are totally wacky?
Yeah, so the one thing that is more on the complicated side is like if you look at stuff like this where you have actually concrete types, it's all very easy, right? It gets a lot more interesting when you consider generic stuff, right? Because, well, generics are hard. So
yeah,
for example,
at the best of times.
So we have this method here in the BCL. Actually, let me maybe change the color theme to something that is a bit more on the lighter side. So basically, this method here is searching the contents of the array, and then the last, well, it doesn't really matter if you look at this one, the first.
Do you want to zoom it in just a tiny bit?
Yeah, like this. So basically, the first time we find an element where this predicate here returns true, what we do is we return you that value for this thing, right? So, but this is the generic API, right? On an unconstrained T, right? So any T will work. Well, that means if the array, is of nullable customers, well, then we can give you back a null value just fine, right? Because the array itself may contain null values, right? The problem now is what happens if you don't find a match at all? You still have to return a value, right? And so we return default of T. So if now imagine the array you pass in as a customer array, meaning you'd say there cannot be any null values in the array. Well, it would return you a null value, but the T is customer, right? So that technically the type system now validates itself by saying, oh, I give you a non-null customer, but in fact I give you a null customer back, right? And so you can't express this in generics, because as soon as I put here a question mark, well, that's not correct anymore, because if t is a value type, then it's a completely different representation from if it's a non-value type. So in generics, you can't just put a question mark. It's something you can't do. So
I'm sure we lost half the audience there, because
yeah, that's just one of those things where you as a customer hopefully never, I mean, unless you write generic code yourself, you probably never have to deal with that, because when you instantiate this method here, meaning you run it over a concrete data type, the compiler on the IDE will do the heavy lifting to say, yeah, this thing can return a null value. So it will show you in IntelliSense as customer question mark when you invoke it over a customer array. And so what we have here is basically a custom attribute that says maybe null, meaning it could be null, it could be not null. It depends on what the t is and whether the function succeeds or not.
So what's the value of the maybe attribute as opposed to saying nothing?
So if we don't say anything here, so that if you do it like this, that means the signature will show you, it gives you back a customer. And then subsequent code, when you just say print customer.firstname, you don't get a squiggle in the IDE that tells you may null reference because you couldn't find the customer.
Oh, I see.
And now with this attribute, we say, oh, hold on, we know that this method may return a null value here. So you actually get a squiggle in the IDE if you just call find and just start dotting into that result without checking it for null.
I see. So in this way, we enable this method to participate in the model.
Yes.
In a quasi-useful way, as opposed to not participating at all.
Yes, exactly. And that's kind of the part that is also not necessarily always super intuitive, right? Like, for example, another very common example we have is dictionary, right?
People use those constantly.
So try get value, right? So same thing, right? You have a dictionary of string and customer, and we say, give me the customer lander, and then we didn't find a customer. Well, clearly, even though if your dictionary does not allow to contain null customers, this method has to give you back a null customer. Now, that's generally fine because
right, in the case that that customer is missing from the
if we can't
dictionary.
Find by the key, right? And generally speaking, you're not very likely to accidentally lie reference in this case, because the whole signature here is you're saying if try get value, and then you only use the out variable if the method was true.
Yeah.
And so we actually encoded this as well as a convention where we say, well, we have this maybe null when custom attribute that says, well, this value here may be null if the return value of this method is false.
Yeah.
And so same thing here. Now we can actually, if we look at the, I hope I have a build of the compiler where that actually holds, but let's say I have an actual dictionary here. New dictionary string, comma, customer, let's say, right? And I say if, or let's say I say just dict try get value, right, out var C, and then we just say, let's say C dot first, right?
Yeah, it doesn't matter.
Right? Now here, same thing, I get a squiggle that says derivatives of possible null reference because we know that this thing might be null, right?
Right.
And now if I actually check the return value,
yeah.
now the squiggle disappears.
Yeah.
And that magic is enabled by this custom attribute because we say, well, if the return value of the function is false, then this value may be null. And so these are the kind of ways where, unfortunately, the type system, if you think of just question marks, is just not expressive enough to express these kind of conventions. And so we worked really hard when we annotated the base class library to let the compiler have the smarts to do that. And we really tried hard to avoid cases where the compiler has to literally special case the method. There are very few cases where we have. A common example would be interlocked compare exchange, where the contract is so convoluted that it would be super hard to express that. But for the most part, it's just, even environment fail fast or Debug.Assert are not special case. They just have very simple custom attributes. If you own assertion library, you can totally apply the same custom attributes and get the same behavior.
So what was the process that your team used, which you decided as a team, we're going to go annotate all this stuff, and presumably for the first while, you know, at least once a week, someone would come up with, oh, I don't have the tools to properly annotate this. We need a new descriptor of sorts. What was that like?
Well, so before we start there, let me just start with how we generally thought about annotating this stuff, because there's basically two approaches, right? The approach that pretty much everybody normally would take is you annotate the implementation, and then by annotating the implementation, you also annotate your public APIs. And people ship a single DLL usually where the public API and the implementation are the same DLL. That's not how we ship, right? We have these, what we call reference assemblies, which are basically header files, and then we have implementation on the other hand. So one thing we thought was, well, maybe we can just look at the APIs and convince ourselves where question marks should be, and then just change the reference assemblies, because that would be much easier for us to do.
Totally makes sense. Do it.
Unfortunately, now, turns out we have never had a type system feature for nullable, so we honestly don't know what things can be null and what not. And so we decided early on, like, that will not work. Let's actually do the proper work. Let's actually go implementation first. So we took the lowest library that we have, which is system private corelib, which is basically the, you know, where string lives and int lives.
It's the core library.
It's the core library. And we basically started to annotate that entirely, right? And we basically literally took the, 1,200 files and said, we have 5 devs, you get these files, you get these files, you get these files, and then for every single file, they just said pound null enable, pound nullable enable, and then they just fixed the fallout, and then submitted PRs for all of those things. And so, as they were doing that, our goal was we will not change the code, we will not add any if statements. We will basically just express what the code already does. We will not change the semantics of IL. And by doing that, we found what you just said. We found all these holes like try-get value where, well, we really can't express with just question marks what the API does. So now that means every time now the call side uses dictionaries, we would have to suppress things. You know, that's the one thing we haven't talked about yet, is that I can also suppress warnings, right? Similar to how I have a question mark. So if I say this and I do this, I can now I get a warning here that says, well, you didn't check. I can just bang this and say, no, I know this is not null. You may think this is null, but I know that in my dictionaries I always have a lander floating around, so I know that's safe to do.
Right. This is the one that they sometimes call the damn it operator, right?
Yes.
Damn it, I'm right.
And so we kept track of all the cases where we used the bang it operator, because that's an indicator that either the type system is not smart enough or we have not enough flexibility in the type system to express ourselves, right? Or we just found bugs in the compiler as well. And so then we started filing bugs against the compiler team and said, well, how do we express that? And then, you know, the compiler team, the language designers, they went over that. And the end result is, I can roughly show you where we are with that. There is this namespace system diagnostics.code analysis. There's a few things already in there, like suppress message attribute and exclude from code coverage. But all the other ones are just custom attributes that we came up with that allows us to express the nullability contract, like the try-get value or the does not return thing, for example, right? And these are the only things we ended up having to apply. And I think if you go through corelib, I want to say on the public API side, maybe 50 applications of those attributes.
Okay, that's
maybe
actually
100, something
relatively low.
on that order. On the implementation side, we have a lot of those applications. So one of the things we do a lot in corelib is we don't just throw an exception, because the throw statement in IL is, you know, pretty like a lot of bytes. And so we have these helper functions that basically create and throw the exception. And so the compiler, of course, no longer knows that this method will never return. So one of the things that we apply a lot is the does not return attribute and all the things that construct exceptions and throw them, for example. So that the compiler can actually understand that this will never return, right? Or the other one that we use quite a bit in implementation is everything that is generic, where we have to use the maybe null and attributes, for example.
So back to my flow analysis question.
Yep.
If the flow analysis was more sophisticated, then would you not need the
custom
does
attributes?
not return attribute as much, or that's not the right way to think about it?
Yes and no, right? So you could say if the compiler could do global program analysis, right? Look at every single method, right? Then maybe, but the problem is you have interdependencies now, right? Because methods call other methods, right? So it's very hard for the compiler to have a complete picture. And in a sense, the whole idea of a type system is that you don't have to do that, right? The whole idea of a type system is you declare your inputs and output semantics, and then the compiler only has to look at each individual, edge, if you will, in your graph of functions. You don't have to look through the whole graph, right? And so we still care about compilation being fast, right? We don't want to spend like an hour for some tool to run. Like, I mean, we used to ship this thing called code contracts, where there was a verifier that was a full theory improver that actually did, was more powerful, right? You could express things like, well, I have preconditions and postconditions. You can express, for example, that certain indices have a certain relationship in binary search, for example. And the compiler could prove, or the tool could prove that your code is satisfying that or not. But we don't do that. We try to keep it relatively simple, because it also means that if you look at APIs, it's also relatively easy for you to figure out what's correct.
So this feature wasn't entirely just about like perfect correctness and how much of that we could afford in the schedule. There actually are some inherent trade-offs.
Yes.
That,
I think the number one trade-off, like I think Matt said it really well phrased, like this thing is not designed to do enforcement, right? This is really more geared for, well, the first time you use an API, you don't know what's null and what's not null, right? A good example is hash table, right? Hash table has this behavior where when you index into it and the key doesn't exist, it gives you a null value. Versus dictionary doesn't do that. If it just throws an exception and says the key doesn't exist, right? And so you have to read the documentation today to know that this is the behavior. The idea here is that because we promote these things in the type system, you get the whole experience in IntelliSense and documentation, and everything can tell you what are the expectations. So there's a huge productivity gain in you knowing upfront what the expectations are. That's particularly important for things where we have, for example, interfaces and virtual methods where, well, there's a contract, but it's only written in text, which nobody ever reads, so everybody does whatever they want to do. And so the idea here is that we try to express the intent, and we try to keep honest people honest, right? If you want to cheat and if you want to bypass things, you can figure out a way to bypass the type checker. But the idea is that we just don't do that, right? Our goal is to do a best effort analysis, and that means minimizing false positives, but also minimizing false negatives, right? And so we think we have reached a trade-off that is pretty good, but the proof is in the pudding. So with .NET Core 3.0, the idea is people should opt into the feature and see whether it works for them.
Right. So what's our philosophy on, you mentioned interfaces,
Yeah.
on interfaces and base classes? Because by definition, particularly with interfaces, there's no implementation to kind of reason about.
Right.
Are there any cases that you want to raise in that kind of category?
iCompare is a good example, right? You basically get two values, and you're supposed to compare them, right? And so you have to return an int value that is 0 when they're the same, negative when the left is smaller, and positive if the right is smaller. And so the idea is that you're supposed to handle the case where either argument is null.
Yeah, I knew we were headed that direction.
And so the interface basically now says, yeah, both like the x and the y that are passed to you, you have to assume they are null. So they're basically both marked with maybe null, right?
That makes sense because it's inherent to satisfying that interface.
Yes. And so there's something, or like iQuality compare is the same thing, right? If you call equals, well, one side might be null, right? There are also virtuals on base class that have a similar problem. So the most common example where we argued on the team quite a bit was object.toString, right? So object.toString, clearly, I would argue the intent has always been that you don't return a null value, right? However, we found internally plenty of cases that we return null. Of course, nobody writes return null, but usually you return something else, right? Like you have a name property, or you have a field that is a struct or something.
I get it.
And then, well, those might be uninitialized, so you may actually get cases where toString does return null. And then, of course, now the question is, what should we do, right? So we have two options. We can either say object.toString is marked as not null, and that means now everybody who overrides it will now get a warning if they don't adhere to their contract. But it also now means everybody who uses toString no longer gets a warning that the result might be null.
Yeah, that's the problem case.
Right? The alternative would be we mark it nullable, which now means everybody who uses it gets a warning when they dereference that value, which might be annoying. But if you look at common cases, we convinced ourselves that that's the better angle, because people that call object.toString usually directly forward the value to other APIs that generally accept nullable values, like console.writeLine, trace.write, or something like that, right? And so you will not get spurious null warnings. And then the other thing is, when you're on a derived type, like string builder.toString, every time you have a derived type, the derived type can decide to mark things nullable, right? Even if the virtual base is nullable, the derived type can say, no, I'm not nullable, right? And that's the same thing with any other virtual method, that an overrider can always be more strict, if you will, right? At least for the outputs you return. For the arguments you take, you cannot be, you can be more forgiving, but not less forgiving.
Right.
But that's a general idea where we looked at things and said, okay, what can we do to make it so that people don't miss out on warnings, but we also don't flood their error list with warnings that are unactionable, right, or that we know are very often wrong. So another common example that we have is, every single time you have a struct, and the struct has properties that returns a reference type, strictly speaking, that can be null, right? Because you can always have a default value of that struct where the field is uninitialized, right? But we said, well, that no means if every property and every struct that is a reference type is marked as nullable, that's no longer useful either, right? Because that's probably also not true. So we said, if realistically speaking, most of the time you get the struct from a BCL API where the thing is initialized, we mark it not nullable. If there are cases where you construct it yourself very frequently, then we mark it nullable, because, well, God knows what you're doing in your code, right?
Right.
And so that's kind of the general philosophy of guiding you towards finding null reference exceptions early rather than later, yeah.
So how about we transition to recapping how you turn this on,
Yep.
and if there where that people should look at to kind of get a non-video format of this.
So there's a blog post coming that Philip Carter is writing that has a very in-depth walkthrough for every single custom attribute that we have, why they are there and how they work.
I think you know the URL already.
I do know the URL. It's aka.ms /nullable-blog, I believe,
Yep.
if I remember correctly. The feature is available with .NET Core 3.0 and .NET Standard 2.1, and by extension, all platforms implementing .NET Standard 2.1. But you have to still opt into that, right? So you still have to say either this, nullable enable, or the other option that you have is you can do it by file. So the other way we can do it is we can say anywhere in the file. We can
Doesn't have to be the first line.
Doesn't have to be the first line. In fact, I can move this all the way to here.
Okay, for kicks.
And then you can even.
But then it's still whole file scope.
Nope.
Oh, no, it's everything below.
Yes, and you can also turn it off again. You can also say disable.
But you don't have to write that if you want it to go to the bottom.
Yeah, it's just to the bottom, right? It doesn't carry forward to the next file. That would be really weird. But you can now also decide that you say, oh, I have.
Right. So, but in this case, where you've enabled it just for the customer class, your uses of that are not using the feature. Is that right?
Correct. So it controls both things. It controls. So there's also other directives you can use that control analysis versus how the type should be interpreted. But the way I've written it right now, it means this is considered not null. This is considered undefined, right? It could be null or not null, right? It's basically what string means today. Like we call it
unenlightened? No.
I forgot. That was a funny word for that. I want to say ambivalent, but I don't think that was oblivious. That's what it is.
Okay, oblivious.
So basically, it's because it could be null or not null, right? And so you can think of it. This is string. This is string bang, right? The non-null string, and this is the nullable string. These are the three kind of types. And so you could do that too, but I would rather recommend don't do that. Like make a decision file by file. So what I have done usually is when I opt in existing code, I don't turn it off for the whole project. I turn it on file by file, fix all the warnings, remove all the #nullable enable, and then enable it for the project.
Yeah, once you've gone through all the files.
If you have a large existing code base where it will take you basically multiple days, weeks, in our case it was weeks, to actually enable that, another way you can do it is you can turn on nullable on the project project-wide, immediately commit this change, nullable disable.
Okay, go the other direction.
Because now that means every single time somebody adds a new file, they're by default in the nullable land, so you don't accumulate more debt as you're going forward, right?
Yeah.
And then you just remove those guys and fix the fallout. But that's the other way to make that work.
Okay, so this is only in Visual Studio 2019.
Correct.
And basically, you need to follow the kind of .NET Core preview. So right now,
Yes.
basically by the time, I think 16.3, when it ships, that'll be the good one.
Yeah, I forgot what the version of Visual Studio is, but yeah, that sounds right.
Yeah, I think that's the right one.
Yeah, it will, of course, also work in VS Code, right? The latest version of OmniSharp,
latest.
that will also work. And right now, like, we don't have, you would expect that we have here like a quick fix or something, but so there's still stuff we need to work on to provide you with a bit more of a richer experience. But the compiler feature is done, as in we believe the flow analysis the compiler does is correct, the way the attributes are emitted is correct. The .NET platform itself is not fully annotated, right? For .NET Core 3.0, what we have done is basically we have enabled the core library, which is about, I want to say, 30% of what you get referenced by default in a console app.
I see. So the rest will be done in .NET 5. Is that the plan?
And the other thing is we consider our annotations in preview. Because as I said, there are some elements where Object.toString where there really isn't the correct answer, right? There are opinions on what is more helpful for the customer, but strictly speaking, either one would be correct, right? And so we made some decisions. We believe they're correct, or more usable or more useful, I guess. But we want customer feedback on those, so we will probably.
Where should they give that?
Sorry, what?
Where should they give that?
So there's a blog post coming where Philip talks about this. There could be comments on the post, file bugs on GitHub.
On .NET/CoreFX?
Yep, CoreFX, or the feedback tool here as well would also work.
Okay.
So the idea is, consider those previews. However, we want library authors, like if you have a NuGet package, we want you to opt into that and start annotating your own library. Because the whole value of this feature is only as big as much of the APIs the customers use are annotated. That includes the framework, of course, but also, Newtonsoft JSON, right? Everything else that people use. And so, unfortunately, this whole ecosystem will take a while to get this, which is why we want library authors to start basically with .NET Core 3.0 and .NET Standard 2.1. Don't wait for 5.0 where everything's annotated. Get ahead of the curve and try to get it done.
Makes sense. Okay, I think that's pretty solid for one show. Well, thanks as always.
Pleasure.
Being on the show. And this was a kind of a summary of nullable reference types with Immo, who's one of the designers of this general area. Thanks again.
Thank you.